By now, you should know the basics of the C programming language. Perhaps not enough to be an expert, but enough to know that there are some similarities and some differences between C and Julia. Now, what if there's some aspect of C that's not available in Julia, but you still want to use it inside of your Julia project? Is there a way to use C code in Julia? Well, let's find out. Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I'm your host, the Dabbling Doggo.
I dabble.
By the end of today's tutorial, you'll know how to call C code from Julia. You'll also know some of the features of C that are supported in Julia, so you can use C-like code inside Julia without actually writing any C code. Knowledge of both C and Julia is required for this tutorial, so I'm assuming that you've watched the first 4 episodes of this series, and that you have Julia, C, a C compiler, and VS Code already installed and set up on your computer. Okay, let's jump into the code. Let's start by setting up a simple example just to establish the workflow for calling C code from your Julia project. In the Explorer panel, create a new file called workflow.c. Let's use a simple, contrived example for this demonstration. Notice that we did not include a header file, nor did we include a main function. This code is just the function declaration and definition. Of course, you would never do this in real life, but let's pretend that this code represents some amazing function that you can only write in C. Or perhaps it's C code from an existing library, and you don't want to rewrite it in Julia. Wouldn't it be nice if you can somehow access this code from inside of your Julia project? In order to do that, we first need to create a shared library file which contains this code. This is optional, but I'm going to create a text file with some instructions on how to create a shared library. These instructions will be available in my GitHub repository. You can create a shared library file using your C compiler. So for Windows and Linux users, you'll use GCC. For Mac OS users, you'll use CLang or Clang. The file extension for the shared library is different depending on your operating system. It's .dll for Windows, .so for Linux, and .dylib for Mac OS. In order to create a shared library, you need to enter the commands into the command line in the terminal window. I don't use the terminal window a lot, so I find it helpful to have these commands in a text file somewhere so I can just copy and paste the commands. The commands are not intuitive, so unless you're a regular user of the command line interface, it's easy to forget these commands. In any event, here are the commands for Windows. I'll provide an explanation after writing the commands for the different operating systems. The commands for Linux are identical with the exception of the file extension. I have to confess that for Mac OS, I couldn't find a definitive source, so I think these are the commands. Unfortunately, I don't have access to a Mac, so if you're a Mac user, please let me know in the comments below if these commands work. Since I'm using Windows, let's go through the commands for Windows. GCC is the name of our compiler. -F is a GCC flag. PIC stands for Position Independent Code. Using this flag instructs the compiler to generate code that is suitable for use in a shared library. There are 2 versions of fpic, one using a lowercase pic, and the other using an uppercase pic. The version using the lowercase pic generates a smaller, more efficient file, but may result in an error depending on your code and/or operating system. The version using uppercase PIC generates a larger, less efficient file, but generally always works. So the rule of thumb is to try the lowercase PIC first. If you get an error, then use the uppercase version. Going back to the commands, using -shared produces a shared object which can be linked with other objects to form an executable. Filename.c is the file that contains your C code. Of course, replace file name with the actual name of your file. -o means output. libfilename.dll is the name of the new dynamic link library file that you want your compiler to create. By convention, shared library files start with lib, followed by the file name of the source file containing the C code. If your terminal panel is not already open, you can open a new terminal panel by going to Terminal, New Terminal. Copy and paste the appropriate commands for your operating system into the terminal window. You can just right-click to paste the commands. Be sure to change the file names to workflow before hitting enter. After you hit enter, you should see a new file appear in your Explorer panel named libworkflow.dll. This is your shared library file. Now create a new file called 01_ccall_workflow.jl. You have a couple of different options when calling C code from Julia. The first option is to use Julia's ccall function. The second option is to use Julia's ccall macro. I'm going to show you how to use both options starting with the ccall function. But before we can use the ccall function, we need to use a Julia standard library named libdl, which is Julia's dynamic linker standard library. Once you hit Shift-Enter, the Julia REPL should appear. This is optional, but I'm going to dock my REPL next to my code. The next step is to create a pointer to the shared library file. You do not need to use a file extension, since Julia should automatically select the appropriate file extension for your operating system. Next, we need to create a pointer to the function in that shared library. DLSym stands for Dynamic Library Symbol. In Julia, the name of your C function needs to be loaded as a symbol data type. Next, we need to declare and initialize the variables that we want to use in our function. Finally, we need to create a wrapper for our function. We can do this by defining a Julia function that uses the ccall function to call the function from our shared library file. I just happen to be using the same name for my Julia function as the name of the function that we created in C, but you can use any name for your Julia function. So let's discuss the arguments included in the ccall function. Func is the variable that's pointing to the function in our shared library. cint stands for the int data type in C, which is the data type that we used in our function definition in our C code. When using the ccall function in Julia, all of the data types from C are preceded by an uppercase C. So if we had defined our function using type float, then we would use the uppercase C followed by a lowercase float. That third argument must be in the form of a tuple, even if there's only one element. This tuple contains the data types for the parameters used in the function definition in the C code. Since both of our parameters are of type int, we use cint for both parameters. Finally, the last two arguments contain the parameters used in our Julia function definition. It may not appear that anything has happened, but you should now be able to use the myadd function that you created in C here in Julia. Amazing, right? Let's try another one. This may not seem that impressive, but think about what we just did. We wrote code in C, and now we're using that C code here in Julia. So, what's the catch? Let's try another example. Of course, this doesn't work, since the function that we defined in C only works with integers. So keep this in mind when you're calling code written in C. Before starting the next section, let's close out of our current Julia session. I'm not sure if this happens to any of you, but I've noticed a quirk in VS Code when I dock my REPL next to my code. If I exit the REPL while it's docked next to my code, I can't bring up a new session for some reason. But if I move the REPL back to the terminal panel, and then exit out of the REPL, then it works just fine. So that's what I'm doing here. Now, let's take a look at how to use the ccall macro. The workflow for using the ccall macro is almost identical to the workflow for using the ccall function, so you can copy and paste the code from above. Now, before you run any code, we need to change the code for the ccall. So let's discuss the syntax for the ccall macro. In order to use the ccall macro, replace the ccall function with the ccall macro and remove the outer parentheses. The variable func now has a $sign in front of it, and it's immediately followed by the tuple containing the parameters for the function. The syntax inside the tuple is the same as Julia's syntax for declaring data types for function parameters by using the : operator. The tuple is immediately followed by the : operator, which assigns the data type for the actual function. The end result will be the same, but the syntax for the ccall macro is definitely different than the syntax for the ccall function. I don't have a point of view as to which syntax is better, so I'll leave it up to you to decide whether you use the ccall function or the ccall macro. Now, let's go through this code and execute it line by line. So you should get the same results using the ccall macro. Pretty cool, right? This was a simple example in order to establish the workflow. Now let's take a look at a slightly more involved example to reinforce our understanding of this workflow. In this example, we're going to create a function in C which uses a switch conditional statement. The switch conditional statement is not available in Julia, so let's see if this C code will work in Julia. Close the workflow files for both Julia and C. Also, close out of your Julia session. In the Explorer panel, create a new file called example.c. Start by including the standard I/O header file, but don't include a main function. Let's declare and define a new function called mySwitch that will use a switch statement to decide which output to display depending on the integer used as the function argument. Inside the curly brackets, type in switch, then hit enter to have VS Code autocomplete the syntax template for you. For the expression, let's use the parameter named direction and then fill in the switch statements using the same code that we used in the last tutorial when we learned about switch statements. So we know that this code works since we used it in the last tutorial, but will it work in Julia? Let's follow our workflow and create a shared library file using the C compiler. Like last time, copy and paste the appropriate commands for your operating system into the terminal. Change the file names to example, and then hit enter. In the Explorer panel, you should see a new file named libexample.dll. Create a new file called 02_ccall_example.jl, and let's repeat the workflow that we established in the last section. Start by using the libdl standard library. Again, I'm going to move my REPL panel, but that's totally optional. Next, create a pointer to the libexample shared library file. Next, create a pointer to the MySwitch function within that shared library. Finally, create a wrapper for that function. I'm going to name my Julia function Compass, but you can name it whatever you like. So as you can see, we're using the cvoid data type, since our C function will only display an output and will not return a value. Even though there's only one parameter used in this function, you still need to enter the parameter data type as a one-element tuple, so don't forget that comma inside the parentheses. And that's it! We should now be able to use the C function using Julia code. Let's test it out. If you look in the REPL, you should see all of the outputs. How cool is that? Now, let's try using the ccall macro. Close out of this Julia session by using Ctrl-D. You can copy and paste the code from above. Go to the function definition and change the ccall function syntax to the ccall macro syntax. Just like with the ccall function, the data type for the function parameters must be in the form of a tuple, so don't forget that comma inside of the parentheses. And that's it! You can now go through and run the code line by line. If you look at the REPL, you should see the results. So the ccall function and the ccall macro work the same way. It's just a matter of personal preference regarding which syntax feels more natural to you. But it's nice to know that you have a couple of options. Now that you know how the ccall function and the ccall macro work, you don't need to complain that C offers something that Julia doesn't. That's because you can now tap into everything that C offers from inside of your Julia project. Now, what about going the other way around? Can we call Julia code from inside of our C code? Let's discuss. There's a section in the Julia documentation that describes how to embed Julia code inside of C code. Conceptually, this is very interesting, since that implies that you can create an app using Julia code, and then embed that code into C code so that you can use the C compiler to create an executable file. If this sounds too good to be true, that's because it is, at least for me. I have to confess that I have gone through this documentation and I have not been able to figure out how to get this to work on my Windows computer. Have any of you been able to do this successfully on any operating system? If you have, let me know in the comments below, because I'm really curious to learn how you did it. Even though this didn't work for me, let's talk about some things that do work. Namely, the printf function from C is supported by Julia, So let's take a look at how to use the printf function inside of Julia. Close the example files for both Julia and C. You can also close the shared library instructions, since we will not be using them again in this tutorial. Also, close out of your Julia session. In the Explorer panel, create a new file named 03_printf_demo.jl. In order to use printf in Julia, you need to use the printf standard library. That's printf with an uppercase P. You can call the printf function in Julia by using the printf macro. With this macro, you do not need to use any of the extra syntax used in C, so there's no need for the parentheses, commas, or semicolons. Let's take a look at a simple Hello World example. You should see Hello World in the REPL. Just like in C, the printf macro does not assume a new line character, so you'll need to include the escape character for a new line if you want a new line. Julia's printf documentation refers to a C++ website that provides some examples of various formatting options available with the printf function. I'm going to copy and paste these examples and then go through each one to show you how to use them with the printf macro. Spoiler alert, they don't all work in Julia. So all you need to do is remove the parentheses, the commas after the quotation marks, and remove the semicolon. After you hit Shift-Enter, you should see a lowercase a and an uppercase A in the REPL. That's because the integer 65 is the ASCII decimal code for the uppercase A. This example uses the LD format specifier, which stands for long decimal, or long integer. That uppercase L at the end of 650,000 means that it's a long integer in C. If you try to run this in Julia, you'll get an error message, since Julia does not have a long integer data type. You also don't need to use the LD format specifier in Julia, but it should still work. Just remove the uppercase L. Using an integer immediately after the % character indicates the minimum number of characters to display. In this case, there are a total of 10 characters, which includes 1977. By default, the output is right justified. If you like, you can left justify the output by using a minus sign before the number. You can see that 1977 is now left justified. Rather than having white space, you can use leading zeros. So it's a little easier to see here. There are a total of 10 characters, so there are only 6 leading zeros, not 10. The zeros just replace the white space. This next example is a little unusual, and it's a little difficult to see on the screen since the code is so wide. I'm going to zoom out so you can see the code. I'm not sure how many of you will use these format specifiers, but %x stands for an unsigned hexadecimal integer, and %o stands for an unsigned octal. When used with X, the hashtag character will precede the value with a 0x. When used with O, the hashtag character will precede the value with a 0. This next example shows different ways of formatting pi. We've discussed the number following the decimal point before. That just indicates the number of decimal digits to display. If you want to display a plus sign to indicate a positive value, then you need to use the plus character after the percent character. The lowercase e stands for the lowercase scientific notation. The uppercase e stands for the uppercase scientific notation. This last example shows a neat trick that you can use in C to specify the minimum number of characters outside of the format string by using the asterisk character. Unfortunately, this trick does not work in Julia. And this final example you've seen before. It's the same as our Hello World example. There's a special case in Julia that I want to point out. Because the $sign character is used for string interpolation in Julia, you need to use the \escape character if you want to display a $sign in Julia. So now that we have an idea of some of the formatting options available using the printf macro, let's create a function to print out a receipt using a vector of floating point numbers. These are just some random numbers for demonstration purposes. You can use any numbers that you like. As you can see in the REPL, the numbers are aligned using the decimal point. But the output looks a little sloppy, so let's create a function to generate a formatted output. Okay, let's call our function and print our receipt. Now, if you add up these numbers, you'll get a different total. That's because we didn't change any of the values. We just changed the formatting. Pretty cool, right? We covered a lot of material today, so let's break here and go through a recap of what we just learned. Today, you were granted access to 50 years of software development in C that you can use with your Julia project. What will you do with your newfound gift? But seriously, we learned how to create shared libraries from our C code by using the C compiler. Then, we learned how to call C code from inside of Julia by using the ccall function and the ccall macro. We also learned how to use the printf macro from the printf standard library. Sadly, this concludes our exploration of the C programming language. We covered a lot of material over just a few tutorials, but this was by no means meant to be a comprehensive course on the C programming language. There were a lot of topics that I did not cover, so if you're interested in learning more, there are lots of C programming language tutorials available for free on YouTube. As for this channel, it's time for us to move on to C++, which will begin in the next tutorial. So I hope to see you then. Well, that does it for today. If you made it this far, congratulations! If you enjoyed this video and you feel like you learned something new, you can support me for free by smashing that like button, leaving a comment, sharing this video, and by subscribing to this channel. If you'd like to support me financially, you can make a one-time contribution by using the Super Thanks button. You need to be logged in to see the Thanks button. For ongoing support, please consider joining and becoming a channel member. Channel members get early access to all of my new videos. New tutorials are posted on Sundays/Mondays. Thanks for watching, and good luck on your Julia journey.